Hi all. Today we'll be discussing the LeetCode problem of the day, n repeated elements in size to an array. So here you're given an array with the following properties. The array size is 2n and it is formed with n plus 1 unique elements. So suppose my array length is 8, then n will be 4 and the array will be formed with n plus 1 unique elements. So the unique elements might be, suppose, let's say 2, 4, 1, 7, 6. So out of this n plus 1 unique elements, exactly one element is repeated n times. So suppose let's say 7 is the element which is repeated 4 times. So the entire array will be something like this. 2, 4, 1, 7. All these numbers repeat only once. 6. And then the one element repeats the other n times. So this might be one of the array. So now you have to return the element that is repeated n times in this array. So in this example, you have to return 7 because in this array, all the elements repeat once, only 7 repeats n times. Now let's check the examples. So in the first example, we have n equal to 2. So 3 is repeating 2 times and the remaining elements only repeat once. So the output will be 3. In the second example, the size is 6. So n will be 3. You can see that the number 2 is repeating 3 times and the remaining numbers are unique. So we have to return 2. And in the last example, the array size is 8. So we have n equal to 4. And if we see in this array, the number 5 is repeating 4 times and all the other numbers are unique. So the answer will be 5. Now coming to the constraints, the value of n will be up to 5000 and the array length will be 2n and each element in the array will be from 0 to 10 power 4. And it is guaranteed that number contains n plus 1 unique elements and out of which only one repeats n times. Now let's go over the approach. So suppose we have the array. Now in this, I will claim that if in any one of the 3 consecutive elements, we see that any element is repeating, then that will be our answer. So we will check all possible 3 consecutive elements. So first is 3 and we'll check if any of the element repeats in this. And if any element repeats, that's the answer. If not, then we'll check the next 3 elements. If not, the next 3 elements and so on until the last 3 elements. So in any of the 3 consecutive elements, even if one of it repeats, then that will be the answer. So now let's see why this can be true. So I'll try to give a proof for this. Let's say our n is 5. So that means we have n plus 1 unique elements. So let's say the unique elements are 1, 2, 3, 4, 5, and 6. So out of these 6 numbers, one number repeats 5 times. So let's say that the number 6 repeats 5 times. So the array will be something like this. 6 will be repeat 5 times. So the array will be formed with these numbers, but in any order. So now let's try to form the array. First of all, let's put only the unique elements. 1, 2, 3, 4, 5. So now in this array, I have to insert the remaining 5 6s in this array. And to insert it, I have a few positions where I can insert. I can insert at the start of the array. I can insert at the end of the array, or I can insert anywhere between the elements of the array. So now let's say in this gaps, I can choose to insert the 6 or I cannot choose to insert the 6, or maybe I can insert multiple 6s here. So suppose I can put 3 6s here and then maybe 1 6 here, 1 6 here. So this will be my array. So my final array in this case will be something like this: 1 2 6 6 6 3 4 6 5 6. So this will be my final array. So now let's see if our theory is working, if our claim is working here. So at any point, if I put more than 1 6, suppose I put two sixes in any point, then what we have claimed is that we need to check every 3 consecutive elements. And out of them, if one of them is repeating, that will be the answer. So in this case, suppose if we pick this as our 3 consecutive element, we see that the first 2 6s are repeating. So 6 will be our answer. Or maybe similarly, if we check this 3 consecutive elements, we see that the 6 is repeating. So 6 will be our answer. So at any point, at any place, if we put more than 1 6, suppose here as well we put more than 1 6, then we will find our answer with our theory. Maybe in the starting also, if we put 2 6s here. So if we check the first 3 elements, 2 elements are repeating. So 6 will be the answer. Now let's say that at any point in the any empty space, I will not put more than 1 6. So in that case, let's see if we are really able to form our answer. So here we have 5 6s and we have 6 places. So if I exclude this place, I have to put all the 6s in the remaining other spots. So if I do this, we can see that if we pick any of the 3 consecutive elements, a 6 is repeating. So we can find our answer. Similarly, if I maybe exclude the last place and spread out my 6s as evenly as possible, then also I can find my answer. Here we can see that in any 3 consecutive, in at least 3 consecutive elements, a 6 is repeating. So that will be our answer. So the spread can be something like this as well. So here 6, 6, and here we put all the 3 6s, maybe 2 6, and here we put a 6. So like we discussed previously, in any slot, if we put more than 1 6, then because of that only we will find the answer. So we are trying to avoid this case. So if we spread our 6s evenly also, we are finding the answer. Now let's say I want to skip this part and put the 6s in the other places. So if I put a 6 here, 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 and here, then as well, if I see this is a 3 consecutive elements and my 6 is repeating, so I will always find my answer. So the only exception to this is when our array size is 4. So that means when our n equal to 2. When we have n equal to 2, let's say the numbers are formed with 1, 2, 3, and 3 is the one which is repeating. So first I'll insert 1 and 2, and I will have 3 choices where I can put my 2 3s. So if I put my both the 3s in the same spot, I can always find my answer. And similarly, if I exclude this spot and I put my first 3 here and the second 3 here, then also I can find my answer. But the only case where I won't be able to find my answer is if I skip this place and I put a 3 at the starting and I put a 3 at the ending. So in this case, the array will be 3, 1, 2, and 3. So here we can see that the first 3 doesn't have any repetitions, and the next 3 elements also doesn't have any repetitions. So in this case, we won't be able to find our answer, but this is the only exception. So we can say that if we check all possible consecutive 3 elements and if we still didn't find the answer, then we can just return the first element or maybe even the last element, because that will be our answer. Now let's quickly code the approach. So I'll just run a for loop to iterate on all possible 3 consecutive elements. So I'll start from I equal to 0, I less than nums dot length, but I'll only iterate till the third last element, because I am checking in the 3 consecutive set. So first thing, if nums of I equal to nums of I plus 1, then we can return nums of I. Let me just visualize it. Suppose this is our I. This is what we are checking. I plus 1, I plus 2. In this 3 subarray, we just need to check if any element is repeating. So this is the case where the I and I plus 1 are repeating. Now let's write a case where I plus 1 and I plus 2 are repeating. In that case, I'll just return the repeating element, which is I plus 1. And finally, the last case, the I and I plus 2, if they are repeating. So if nums of I equal to nums of I plus 2, I'll return nums of I. So at the end, when the for loop is done, if we didn't still return anything, then that is our special case where the array size is 4. We can return the nums of 0 or maybe even the last element. So for simplicity, I'm just returning nums of 0. Let me test it now. Yeah, so before submitting, let me quickly do a dry run for the input. So in the first input, we have the array as 1, 2, 3, 3. So first our I is here. We'll check for the first 3 elements. None of it is repeating. Then I moves forward. Now nums of I and nums of I plus 1 are not same. But if you see the second condition, nums of I plus 1 and nums of I plus 2 are same. So we return nums of I plus 1, which is the 3. So for this, it's matching. Now in the second example, 2, 1, 2, 5, 3, 2. So here as well, I is here. We can see in the third case, nums of I equal to nums of I plus 2. So this is I plus 2. So we return nums of I, which is 2. And finally, in the last example as well, we have 5, 1, 5. So again, nums of I is equal to nums of I plus 2. So we can simply return nums of I. So our claim was correct. We only need to check the 3 consecutive elements. So let me submit now. Yeah, and it works. Finally, let's do the time and space complexity analysis. So for this problem, both are pretty simple. The time complexity will be order of n, since we are running a loop once. And for the space complexity, it will be constant, order of 1, because we are the only variable we are initializing is the iterator I. I also have the code in Python. If anyone wants to view it, I'll add this in the description as well. And let's catch up in the next video.